Okay, so here are my quick notes for chapter 17, which is comparing groups. This is just going to be a video on how to compare two proportions, and then I'm going to make a separate video on how to compare two means. So here's the deal. What we're going to now do, instead of comparing, so we used to compare one group, the sample, to the population, right? Our P naught, our guess. Now, if conditions are met, we can compare two groups. So we can compare two groups to one another. And what we used to refer to as a 1 prop z-test will now be referred to as a 2 prop z-test. But it also is referred to as a test on the difference of two proportions. So we want to keep in mind that in math, the difference of something is referring to subtracting something. So we're going to go over the conditions that have to be met at the end, but I would like to talk about what an interval might look like in this case. So let's remind ourselves that we'd have sample 1 and sample 2, right? So we would have a proportion from the first sample, which would be like the number of people who said yes, so like number of yeses over sample size. And then I'm going to repeat this for the second sample, except I'm not going to label these two, but this will be the number of yeses in group 2, and then sample size for group 2. So this would be group 1, just so we're clear, and this is all from group 2. So just like in previous examples with proportions, we are either provided with n and p, so we can find an x, or we are given the number of people who said yes over and the total number of people who answered a survey. So a confidence interval, which would be a 2 prop z interval, would look something like this if we wanted to think about it in terms of differences. Uh-oh, guys, I'm just moving my slides around. I don't mean to. Okay. First, I take the difference. So I take group 1 and subtract group 2. And then from the difference, we add and subtract the margin of error. So the big key change here is that the middle is not P hat, it's P1 hat minus P2 hat. So I like to make this comment about groups, right? So for when we compare groups, compare groups, right? We have these choices of what could happen because when I subtract two groups and they are the same, the middle would be 0 for this interval. So if 0 is inside the confidence interval, then we cannot claim the groups are any different. So what that means is, if I find an interval that spans 0, which like the first value, the lower bound is negative and the upper bound is positive, then the 0 falls somewhere inside of that interval, and we cannot claim that there has been any form of a change. But if the interval is all positive or all negative, we can say which group has the larger sample statistic. And I'm going to leave this very broad because sample statistic in this case could refer to so far X bar or I'm actually not even going to write that because I don't like that. X bar or P hat. But then in this case, for this example, it's like P1 hat and P2 hat. So when we do confidence intervals, in this case, we want to be careful and be looking at the signage going on with the interval. All right, I'm going to jump to a new slide here. All right, so what would we do if we were going to have to do this in the calculator, right? So if we were going to test hypotheses for this, we would have a null hypothesis and an alternative hypothesis, and our null always has an equal sign in it. And so I want you to think that if there's no change, then we would be assuming that the first proportion is equivalent to the second proportion. So we assume that the groups are the same. And then we make some kind of a guess, right? So we can put a direction to it. Like maybe we think group 1 is actually bigger than group 2. Or maybe we think I don't want to do that. Maybe we think group 1 is smaller than group 2. Or maybe we don't know if one's bigger or smaller, but we just believe they're not the same. So we still have the exact same 3 choices for our alternative hypothesis. And when we go and run this as a 2-prop z-test, we need very specific entries into the calculator. We have to provide the calculator with x1, n1, x2, n2, and the direction of, I don't need a comma there, the direction of the alternative hypothesis. Okay, so we need to provide it with a ton of information. This would be the same if it was an interval. So you could actually put that this is true for a a 2-prop z-test or a 2-prop z-interval. And then the output is a test statistic, which is a z-score, and its associated p-value. So then you would make a conclusion, and you're going to compare the p-value to the alpha level. And I encourage you to go back and look at the notes from chapter 16 if you're worried about wording and stuff like that, because I did a good comparison of p-value and alpha there. It's always the same language, so if p is less than alpha, we will reject the null, and if p is greater than or equal to alpha, we'll fail to reject the null. Okay. Finally, we want to talk about the conditions here. So the required conditions. These conditions are the same as the conditions for a single test on one proportion and comparing it to its population, except that we're now talking about 2 groups. So we're going to do all 3 of them. Independence, we're just going to rewrite them and refer to them in terms of both groups. Right? So we want to make sure the samples were randomly selected. This ensures that the 2 groups and the subjects themselves are independent. We also have to assume that the groups are independent, right? There's an independent groups assumption, which I'm not going to bother writing down. Oops, I'm sorry, guys. I keep messing up the size of the slides. I don't know if you can see that in these videos. Guess I'll find out when it's over. The second one here is success, failure. And this is like a little bit trickier now because we do have to test in both groups. So we want to make sure x1 is greater than or equal to 10, n1 minus x1 is greater than or equal to 10. So this is the successes and failures from group 1. But we also have to test group 2. So we need to know that the people who said yes in group 2 and that the people who said no in group 2 have a higher level than 10 as well. So we need to test this for both of our groups. And then finally, the 10% condition, we want to make sure that N1 and N2 are less than 10% of their, that's supposed to say respective populations. And if we verify that our conditions have been met, then we are able to either make an interval or run a test. So now you can go ahead and keep watching the videos to find examples for 2-prop z-tests and intervals.